Okay, good evening, everybody. So let us start our lecture this evening. So I see there are only 22 people joining online. Okay, even it is online, I expected more people to see you online, but I see only a few. Okay, so as usual, so let us start by looking our schedule today. So according to our schedule, right, we are in week 6. Sixth week, right? So we will complete object-oriented principles and polymorphism and casting with respect to interfaces and abstract class. Okay, whatever I say, then we will discuss these steps. So according to our slide, so this is actually part 5, putting all together. So in our previous lectures, we discussed actually, I think I discussed this, but without looking these slides. Okay, honestly, actually, I do not need to see these slides also. I can go ahead free of hand. I don't even need to see the book, any book. Okay, so we see that we are at the middle of this semester, right? So by today, so whatever we will finish, so we will complete object-oriented programming principles. And if you understand these, like as we are discussing object-oriented programming, class, object, inheritance, polymorphism, abstract class, interface, and then data hiding and encapsulation. If you understand these principles, then you are good in object-oriented programming. Okay, so let us open our slide. This is the last slide. Okay. So according to our slide, so it says putting all together. That means all means class, object, inheritance, abstract class, interface, like polymorphism, all together in one or some programs. Okay, we're going to discuss. So as you know that these are the actually main things you need to learn, you need to know about object-oriented programming. So far we know what is an inheritance. An inheritance is a process or technique through which an existing class can be reused, or an existing class can be extended or inherited in another class. In that case, the properties of the existing class remain unchanged, but that can be altered or changed or extended in a child class, in another class that we call child class, and the existing class we call our main class or old class or our parent class or our base class. So as we discussed, right, so mammal class, so this is a top level class, that is our parent class, and it has attributes. So minus sign means, you see the minus sign, that means these are private attribute, and if you see plus at sign, that means there are public attribute. Okay, and breathe is a method that is public. Okay. Okay, so with an angle bracket, that means these are the field or attributes. For instance, attributes are actually the variables that hold value for an object of that class. So as we discussed in our last lecture, a class is a blueprint or a concept. Okay, a class is not visible. Okay, class is just a concept or a blueprint. It will tell us how an instance of that type will look like. For instance, if we say building is a class, then if you hear the word building, then you assume that it has some rooms, it has some entrance, it has some exits, it has some windows, something like this, right? Now there are different kinds of building, like office buildings, house buildings, apartment buildings, on it.
Would a pen factory count as a building?
Sorry?
Would a pen factory count as a building?
Yeah, that is a factory, is a building, and maybe a factory also is a building. So by looking, by when we say a building, right? So all of these are buildings. So we, as when we hear the word building, right? And also we see a building, that mostly we can recognize that what kind of building is this, right? We can recognize that first of all, this is a building. At almost 99% cases, you will see that you will recognize that it is a building. Okay, you will not tell that, no one will tell that, oh, this is a tree, this is a vehicle. Definitely a vehicle is, or a building is separatable from a vehicle, or a tree, or another object, another thing, right? So here we say building is top level, like mammal. So we say mammal is a concept, right? And then mammal.
Professor, I don't mean to interrupt, but I have a quick question.
Yes.
Have you started or finished grading the test as of yet?
Okay, we are almost done. Hopefully we will finish tomorrow.
All right, cool.
So hopefully we will publish our grade tomorrow afternoon or by this weekend. Hopefully tomorrow, almost done. Okay. So also mammal class is a top level class, but it can have another top level class. We say an animal. If we say animal can be top of that animal of mammal, right? So sometimes we declare some class abstract class, right? So an abstract class cannot have. So what is an abstract class? A class that contains an abstract method, that is called an abstract class. So in this class is, although it is abstract, it does not contain any abstract method, right? An abstract class may not contain an abstract method. Usually it should contain an abstract method, but this is why the difference between an abstract class and an interface is that an interface is 100% abstract. Okay, there's a background sound coming from someone. So if there is a background sound from your side, please keep yourself muted. Okay. And in this case, interface, okay, it's gone. No, still. So in interface is, okay, also abstract. All interfaces are abstract and 100% abstract. And okay, so everything in an interface, if we add more methods, so those are also abstract, but we do not need to explicitly mention that it is an abstract keyword. Okay, so in abstract method, we cannot have an implementation, right? We cannot have a body. Okay, and then where the implementation will be in another concrete class that will inherit this interface, that will have this implementation. Okay, so the breed over here, although it lies within an abstract class, it is not an abstract method. Okay, so
Professor, I have a question.
Yes.
Can we have variables in the interface?
Yes. In our last lecture, I discussed we may have variable. Okay, you may have variable.
And what is it used for?
So, for instance, if you put a variable that, for instance, if you say red car, so like all cars. So if you declare an interface as red, like red dog, okay. For instance, if you want to declare a dog, that will be red. I'm sorry. What is coming precision form? Give me 1 second. What is coming precision form? I need to take off the precision mode. What is precision mode coming?
Hey, Professor, I hate to interrupt again, but I had a question about the test.
Yeah. So, yeah. Do you see my screen? Okay. Screen. Okay. Yeah. Go ahead with your question.
So there was a question that, like, I'm guessing most of the class got wrong. The question talking about the pre-increment and post-increment and the reference keyword. Most of the class got it wrong, and you said last lecture that you were going to go over it, but you didn't get the chance to. And I was wondering if you could go over it now.
Okay. So better let us publish our result, test result, then we will discuss in our next lecture. Okay.
Yep, sure.
In the
Cool.
test,
Right.
in the text lecture, so I'm giving you example code. Okay. So you see, when you see your grade, you will see example code. Then if you understand from there, that's fine. Otherwise, we will discuss in our next lecture. Okay. So in our last lecture, we went through, so an interface, for instance, we are talking. So if you want to declare, or if you want to deal with only dogs that are black dog. Okay, so that color are black, right? So there is no option that will be different color. So in that case, you can declare an interface like black dog. Okay, so then in that case, color is a fixed color, right? The black. In that case, you can say color is black. String color equal to black. So in that case, you can have a variable in an interface, but that is a fixed value. Okay. So in our previous programs, we discussed this, and then we discussed, like, for instance, so cat, so like this, like, okay, for instance here. So in order to understand this, actually, if you understand this slide, okay, if you understand only this slide, so then you will understand 75% of object-oriented programming principles, because it has all or many like object-oriented principles applied. So in order to understand each of these statement, you have to go each of these statement individually. Okay, and then you have, these are context based. So context are defined will be in previous classes. So here mammal is an abstract class, right? And talkable is an interface, right? And talk is an interface method, and breeze is a non-abstract method, right? So dog class inherits mammals and talkable interface. Okay, cat class, it inherits only mammal class. So with this context, so let us try to understand this, right? So here, if you see cat C1 equal to new cat. So maybe you will be asked a question, is this statement valid or an invalid statement? Okay, so you will go through like, for instance, if your right side is an interface or an abstract class, then the statement is false. An interface or an abstract class cannot be instantiated. So that, like, say for instance, right side is mammal, right? This one is invalid, not allowed, because, so let us mark not allowed, so as red, because right side is a mammal. Here mammal is an abstract class, right? An abstract class cannot be instantiated, so this is wrong, and this is also wrong, no matter what is in left side. Okay, by this side. Okay, then let us see others. So these two are gone. So, and then ask a question yourself. Okay, are all cat? If your answer is yes, then this statement is true. So yes, we know that all cats are cat, right? This statement is true. Are all dogs dog? Yes, so this statement is true. Are all cat dog? No, right? Yeah, this class, let us make it interactive and everybody speak out. Okay, if there is no background side in your side, then you can speak out. Okay, so this one, it is invalid because all cat, or at least some cat, are not dog. So this is invalid. Okay, so similarly, all dogs are not cat. So this is invalid. Okay, now are dog. So if you say dog, talkable is an interface. Remember that T1 equal to new dog. Let us see if this statement, these two statement is true or false. So you say talkable T1 equal to new dog and talkable T2 equal to new dog. Okay, so answer is given over here. Can anyone guess why it is first one is allowed and second one is not valid?
Cat doesn't
Do you,
implement talkable, does it?
yes. Cat has no relation with talkable, right? Cat does not inherit talkable interface. So there is no relation between cat and talkable. So this is invalid. That's good. And we got this one is invalid. So this one is invalid, right? So this one is invalid. And we got this one is invalid. We're giving red. That means will not compile. This will give an error. And now dog. Okay. Okay. So these statements we have asked question: are all dog mammals? Yes, right? Because dog inherits from mammal, right? So dog inherits from mammal. That means all dogs are mammals. All cats are mammals. So these two statements are true, valid. Everybody understand this too?
Yes.
Yes. Yes, sir.
Okay. Okay, thank you. Now say M2 dot breed. So M2 here is a cat, is a dog object, right? M2 is a dog object, right? So let us go to the dog implementation. We need to go to, in order to understand this, so we need to go to the dog class. So dog class has M2 and, okay, so M2 is a kind of dog. Okay, so then it inherits mammals. That means it gets this breed method. It inherits this pet method. This is public, right? So this is allowed. Okay, and M3 here is a cat. Okay, so M3 dot cat, what it will, okay, so M2 dot what it will print. So M2, since M2 it will print this because there is no redefinition of breed method within the dog method, within the dog class. You understand? So dog class does not redefine or we say the terminology overriding. Okay, the terminology is that overriding, and the concept is called redefining, okay, or re-implementation. So dog class does not re-implement. Okay, so breed method. So since breed method is public, so it will get it as is. So it will print generic breeding. So it will print generic breeding. Okay. As we know that when it will print generic breeding, it will not print without quote, right? It will print without quote. It will not print quote, opening and closing. So, but we see that cat class, it redefines or overrides the breed method. So any cat object will print this. So whenever we say M3 dot breed, so then it will print I have kitten breed. So that means this will be printed. So everybody understand? Everybody understand this? What will be printed from there?
Yes.
Okay.
Yes.
Now, thank you. Now last one, then that one. Okay. So M2 dot talk. Okay. So that M2, first of all, M2 is a mammal, right? What kind of mammal? Is a dog mammal. Is a dog. Okay. Is a mammal but a dog. Okay. So these two statements, these are difficult. So sometime for like new programmer. So, but we know that all dogs are mammals, right? But this M2 is a dog. It's a kind of dog. It's a mammal, but kind of dog. Okay. And this M3 is a cat. It's a mammal also, but it's a cat. Okay. So we know that a dog is different from a cat, right? So now, in order to understand what will happen, this statement, whether it is valid or invalid, we need to go to the implementation of dog class. So it refers to dog, right? Dog instance, right? So we need to go to the dog class. If you go to the mammal class, okay, so if you go to the dog class. So in dog class, what is that? Sorry, dog class is a talk, okay? So dog class, does it have talk? Yes, right? You understand? Dog class has talk, and why is talk is over here coming from? It is the overriding of talk method, this method. Okay, that is coming from this talkable interface. Okay. To m2.talk m2. Okay, so it says will not allowed. I'm not sure that it has talk. Okay, so I need to go to program, actual program. Okay, so for now, but m2 is a dog. Why? Oh. Okay, so I will go through this in the live program. Okay, so this one, I will go through this one. Okay, so it's still confusing sometimes to me also. Has anyone except this one? Has anyone any question? Okay, so we have a few more slides. Okay, so if okay. And now I understand. Remember, okay. So it will not. Okay. Okay. The concept is that now I remember. Okay. So talk is an interface method. Okay. In talkable. Okay. This talk so may be different in cat class or dog class and another class. Okay, so we need to specify that what kind of object. So we need to specify this one. It is called typecasting. Okay, okay, typecasting.
Professor, I had a question.
Yeah, before we go to typecasting, I need to go to an example. Okay, yeah, go ahead with that question, please.
Do you not have to override the interface method?
Yes, we need to override the interface. All interface method must be overridden. So talk is an interface method, right?
Yes.
So it is which class, if any class implements or inherit this interface, it must override this one. So the cat class, it does not inherit talkable, right? So it does not require. But the dog class, it inherits the talkable interface, so it needs. Okay. So this is the critical question thing. Okay. So this is the critical question. This is okay. So this will not show an error in compile time, but in runtime it will make an error. Okay. Because the reason is that at runtime m can, so here looking at the code, we know that m2 is a dog right now, but however at runtime m2 could be a cat. We should check to see whether m2a. So this is it's a typecasting or checking. So this is instance of, this is an operator instance of. By using instance of operator, what we can do, we can check whether an object is an instance of a class or not. So if we say if m2 instance of dog, then you will get either true or false result. So in this case, m2 is an instance of dog, right? Here, m2 is an instance of dog. Okay, so here, if m2 is an instance of dog, then we said so m2, like this is called typecasting. Okay, this is called typecasting. So today I want to go through the typecasting with some. So you see that forcing. Let me go to the slides, then I will come with a live program. We have few more slides. Okay, we will come back here. So the next one, okay, it is also typecasting, and so this is good example. Okay, this is a good example. I want to give you homework to study these slides and go with these programs. Okay, so this is a good program. If you understand this, then you will understand a lot. Okay, so this is a new slide. I see that is good. Okay, and let us see. Okay, so actually all of these deal with I want to go through a live program. What is dog class, right? CD CSE1322 review underscore Java. Git. Okay. If you see if I have a dog class or not. Okay, dog package. Okay. So I do have a dog class over here, but different dog class from this class. So this is dog class main, and it has mammal class, and it has dog class extend mammals. Okay, that's good. Pretty much I have everything, but if I want to add, if I would add this code, right? So this mammal class, it has breed. Okay, so mammal class, it has, what is my mammal class? It has breed. Okay, so let me add this breed method. Okay, so mammal class, I'm sorry, mammal class. Okay, mammal class has breed. I'm sorry, this program is written in and C#. System dot out dot println. No, actually it is not abstract class. Okay, sorry, I want to skip this one because it will take time. I cannot finish it tonight. Okay, what I want to do, I want to give you homework to do some study on this page. Okay, but I will discuss this, maybe revisit this in our next lecture. But before I go to typecasting, what I want to do, I want to do casting, typecasting. Okay, so I want to go this specific example. Let us go this specific example, then you will understand the typecasting. Okay, everybody see my screen? Hello.
Yeah.
Yes.
Okay.
Yes, sir.
So what? Yeah. So what we have, very simple program. Okay. So there are two type of casting. It is called upcasting and downcasting. Okay. So let us start with some numbers. Numbers, we know the numbers, right? There are some numbers integer numbers. There are some numbers float numbers, right? Doubles numbers. So if you understand numbers, real numbers, some are integers, some are doubles, then you should understand this. For instance, over here, so if my a is a float number and 55 is an integer number and 10 an integer number, right? So if I print over here, so if I say a equal to plus a, okay, so if I print it, so then what will be my result? Let us come up with our result. Okay, so here my a is coming as float, right? Since I declared a as a float, right? But if I say a is an integer, then I would get 5, right? You understand? I am getting 5. So you see that here, although although a is a float number, but 55 is an integer number and 10 is an integer number. So basically 55 divided by 10, it should be 5.5, right? 55 divided by 10 is 5.5, right? You understand, everybody?
Yes.
Okay, but I am getting the result. I'm getting result 5.0. I'm not getting the 5.5 because the reason is that integer division over here. Integer division means in a division operation, if both numerator and denominators are both integer, then the result become integer. No matter how, where are you putting this, in a float value or double value? No. So in order to get this 5.5, I need to make either of these or both of these integer, yeah, float. So the way, so for instance, if I could do 55.0, okay, so if I say 10.0, okay, so if I say float, if I do this typecasting, okay, then you see that my result will be 5.5 over here. His result is 5.5. Okay.
You couldn't just use the F after the number to designate those numbers as floats?
Sorry, say that again.
You wouldn't be able to put the F after the numbers to designate them as floats?
If, you said if.
F, Frank, F.
Letter F.
Letter F here.
After the numbers.
After the numbers here.
Yeah. I think it's normally a small f.
Okay, it says okay, small f and
lowercase f.
Yeah, small f and then yeah, it will come float. So that is actually typecasting, kind of built-in typecasting. Okay, it will work. That's good thing. Okay, we will, right? Yeah, we will got it. You got it. Okay, so here in order to, so that is actually explicit. Implicit typecasting. Yeah, then you will get 5.5. So that my concept is that I'm telling that either of these or both of these need to be float in order to get a float result, right? You understand this, right? Either by this way or by doing another way that we say typecasting, explicit typecasting, this way. Okay, so okay. Now let us think about like this way. So you understand that. We'll now go to this only 3 course. Okay. So here, for instance, my numbers, I have 2 numbers, n1, n and n1. Okay, and I have an integer numbers. So these are built-in class. Okay, wrapper class, built-in class. Java and C# have this built-in class. So number, that means the real number. An integer, say I equal to 5 and double D says 2.5. Okay. So now I see that, you see that I'll go to this statement. If I say n equal to I and then n1 equal to D, n equal to I, Okay, n equal to 5 and n1 equal to d. That means n1 will be 2.5. Okay, then there is no issue because n and n1 both are numbers, right? A number can be an integer number or it can be a float or double number, right? We know that, right? So either if we assign n1 or n2 by either of these, it is correct. There is no issue. Okay. But look at here, if I wanted to do this, if I wanted to do this, okay, if I wanted to do this, if I wanted to say I equal to n, I equal to n, okay, for any number, for instance, any number, or d equal to n1, okay, so it will not compile because all integers are, okay, so all integers are number, right? But not all numbers are integer. You remember that? If I take a real number system, so let me take a pencil. Let me get my pencil. Okay. We know the line, number line is positive r, and this side is negative r, real number, right? So who understand math? So here at some point it has 0, then it has 1, it has 2, 3, 4, 5, and so on, right? And this side it has -1, -2, -3, -4, and in between these there are decimal values, right? For instance, somewhere it has 0.5, somewhere it has 0.6, and it has maybe somewhere 1.5, right? So all of this number 0.5, 0.6, 0.7, 0.5, 0.5 or something, all of these numbers, there are millions of numbers between 0 and 1, right? There are millions of numbers between 0 and 1. Similarly, there are millions of numbers between 1 and 2, right? All of those are fractional numbers, like decimal numbers, right? But there are only fixed number, a few numbers, okay, those are integer numbers in this number line, right? So that means we can say that all these are the integer numbers. All integers are number, right? But all integers are number, but not all numbers are integer. You understand? So if we say all integers are numbers, okay, but all numbers are not integer. So everyone understand this? This is simple, right? You understand this, right? This thing. All integers are numbers, but all numbers are not integers. Okay. So there are two types of casting. Okay, one is called upcasting. That means what we are doing over here is upcasting. There we are putting, since a number can be assigned with either an integer number or a double number or a floating number. But other side is not true. Okay, I cannot put an integer value for any number. So in order to do this, so this is called downcasting. Okay, upcasting is obvious. Upcasting, this is called upcasting. That means, so if I draw another picture, another picture. For instance, I have numbers. Okay, and then some numbers are subset integers, and some numbers are double, right? Some numbers are double, and some numbers are integers, right? So you see, remember this. This is the inheritance symbol. Okay. So we can say all integers are number, all double are numbers, but not all numbers are integer, not all numbers are double. So upcasting means going from bottom to up. That means from subset to parent class. That is called upcasting, and that is true. You understand that? Will, can you hear me?
Yeah.
Yes, we hear you.
Yeah.
Okay, so this is the concept. Okay, two type of casting, upcasting and downcasting. Okay, this is an interview question sometime, but try to remember this by this figure. Okay, so this is number is a this is the parent class or base class. Okay, and integer and double, these are child class. Okay, so we know that from inheritance, right? All integers are numbers, right? All doubles are numbers, but its opposites are not true or may not be true, right? For instance, all numbers are not integer, all doubles are not, all numbers are not double. So there are two types of casting, right? It's called upcasting. That means when you go from bottom to up, that is called upcasting. Upcasting is always true. Okay, but downcasting coming from opposite order, coming from this order, coming from up to down is may not be true. This is questionable. This is why you see that in inheritance symbol is always like this symbol, this type array. It in inheritance array goes always from bottom to up. That indicates upcasting, and upcasting is always true. So if you draw a UML diagram, also if you draw any inheritance diagram, block diagram, if you give this kind of error, then you will do mistake. Yes, so always go up arrow. This is the reason that we use always up arrow. Okay, so that means upcasting is always true. Okay, so now you understand that why we give up this symbol in the book or everywhere while drawing inheritance block diagram, because upcasting is always true. Okay, now it's time to understand downcasting. Okay, what is downcasting? Downcasting is that we know that all numbers are not integer, but there are some numbers that are integer, right? Will?
Yes.
Yes.
There are some numbers that are integer, right? So that what we can do, you see that if I hover my mouse here, then it is giving me three type quick fixes. The first one, it says add cast to integer. Okay, the second one, it says change type of I to number. Okay, we have I is an integer, right? But it is second option is asking me to change the type of I to number. Then everything will be same. That is no problem. Okay, but the third option is that change the type of n to integer. Actually, this one is n to integer. That means they are asking me three. They are giving me three options. The second and third option, it says make them consistent, same type. Either make I as number or make n as an integer. You see that these two, it says the last this one. It says change type I to number, right? So I is defined on line number 15. Go to line number 15, it says I is an integer, right? Okay, but it is asking me, in order to fix this error, it is asking me, it is giving a suggestion to change I to number, okay? Or it is giving me another alternative suggestion, change type of n to integer. N is defined in line number 14, that is a number, right? So it is giving me these three options, but these three options I don't like to do any of these last two. I don't want to do last two. So what I want to do, I want to do the first option. What is that one? Add cast to integer. If I do select this, what will this? It is called casting. That means what it is doing, we know that there are some numbers that are integer and it is making a filter. Okay, so it is making a filter. That means filter is kind of that thing there. We know that there are some numbers that are integer. So we are filtering out the numbers, those are integer. So for instance, 1, 2, 3, 4, 5, 0, -1, -2, -3, -4. These are the integer numbers, we know that, right? So we are filtering out only integer numbers from this number. Okay, that is what is happening in line number 25. So you understand what is happening in line number 25?
Yes.
Okay, in line number 25, again let me tell you. So we know that there are some numbers, they are integer, okay? So it is what it is doing here. It is filtering out those numbers, those are integers. For instance, we hear from this number line, we see the -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5. These are the integer numbers. We know that, right? So by giving this statement, it is filtering out only the integer numbers. Then this statement is true. Okay, then it will come with a value statement. Now, if you understand this, so in order to make this statement, it is called downcasting. Okay, downcasting means, again, I'm telling you, I am converting or filtering some numbers from bottom. They are coming from top to bottom. Okay, this is called downcasting. Okay, and downcasting is not obvious. Okay, it's not automatic, but upcasting is automatic. So this is why we did not need to use over here number. So it is called upcasting. That means there is something like this by default. Okay, so there is something like this here is default. We do not need to give this. Okay, you understand? This actually default. So this means actually this means number and main and equal to this means, okay, and this means n1 equal to number of d. These are the obvious. Okay, so if you understand this, so how can I fix the line number 26? Can anyone please tell me? I don't like to change any of my existing data, but I want to use typecasting.
Double in parentheses.
Within parentheses, what do you want to type in?
Double.
Okay, thank you. Double. Then it is correct. You understand? So this is called downcasting. Okay, and this is also called downcasting. And this is called upcasting. Okay, this is called upcasting is automatic. Okay, upcasting is not needed. So this is why I do not need to write this. Actually, this statement is equivalent to this statement. Compiler understand this automatically. Upcasting is automatic. Okay, and downcasting is not automatic. Okay. So in order to make downcasting, we need to do explicit casting. This is called typecasting. So you understand? Everybody understand this?
Yes.
Yes.
Okay.
Yes.
So, yeah. I like that if you remember this block diagram, and if you draw yourself with better diagram, then you will never forget upcasting and downcasting. Okay. Now, if you understand this program, okay, so I deal with a simple program. So this program is simple to understand because we are familiar with a real number system, right? So then, if you understand this and remember this, then you can come to this slide to understand this. Why we are doing here? We are converting M2. Okay, we are filtering. We see that what are these statement? This statement says D1 mammal type is mammal, or M2 is a type of mammal, but that is a dog, right? Since we know that all mammals are not dog, right? So there are some mammals that are dog, some mammals are cats. So we need to filter out the mammals that are dog. So how do we filter out? By doing downcasting. Okay, so this is the statement over here. It is called downcasting. So we are using here. So what type over there will be? So we are converting to type over here. Okay, so how did I do that in the program? You see that in the program I converted to the integer and double over here, right? So that means let me go. So integer, this is integer, okay, and this is double. So we are converting to specific type, okay. So that means in this slide, okay, in this slide we are converting to, because the type this m, okay, m object, or sorry, it should be M2. Okay, this one M2. Okay, this M2, it had originally, when we created this M2, it type was the broader type mammal. Okay, but we know that all mammals are not dogs. So what we need to do, we need to filter out the mammals that are dogs. So that filter out is going over here in this statement. That is called typecasting. You understand? So then this statement will be true. Okay, so then in that case, this statement, otherwise it will not true. But if we do typecasting, then this statement will come up true. Because it is not allowed, because all mammals are not dog. Okay, the dog talks, but all mammals do not talk. This is why if we say here dog, this number, then it is true. If we do this, then it is true. But if we do not do this, then it is false. Okay, so it is a critical thing. Sometimes people forget. So how do we convert this? So just with this. So this is converting, M2 is converting into dog. Then since we need to use dot operator, so again we are putting in another parenthesis. So everyone understand this?
Yes.
Okay, and Java has an operator. It's called instance of. This is an operator. Okay, and C# has an equivalent operator. This is called is. RS is. Okay, so that means this instance of operator, it gives either true or false result. So then if we say if M2 instance of dog, if is a, so do in this statement, is M2 an instance of dog? Yes, right? M2 is an instance or a kind or instance of dog. So we instantiated the dog constructor. That means M2. So again, this line you need to, you can write it down. Okay, so M2 is a dog, but its type is mammal. Okay, but here D1 is a dog, but its type is dog. Okay, so all dogs are dog, but all mammals are not dog. Okay, but we are creating mammals that are dog here, and we are creating mammals that are cat. And then in order to in program, this will not any compile time error, but runtime, at runtime it will make an error. So this is why we need to do explicit downcastings. Okay, so this is called downcasting. Okay, explicit, sorry, explicit downcasting. Okay, upcasting is obvious. We know that a few minutes ago we learned that from this program, that upcasting is obvious. Upcasting, it is obvious or automatic, but downcasting is not automatic. So we need to enforce this. Okay, now if you go through this slide and if you remember this program, and if you go through this slide, you should understand and you should never forget. So anyone has any question? Has anyone any question? Okay.
No.
Okay, then there are a few slides. Now you should understand this. Okay. So just here we do use another extra pair of parentheses since we do use dot operator. Then we need another extra parenthesis. Now maybe it is a good time for you. You can practice this program. Okay. This code you need to code snippet. You need to write in your main method. Maybe in your lab you will do some practice. You will write some code like this. Okay. Then we covered this. Okay, so I have a few more minutes. Maybe I can go. Okay, if you go to my Replit account and you see that inheritance student class example, so this is the program. I'm grading this one, so for your reference, I created this program. Okay, so if you see that the code of the program that you're tested in your section. Okay, there is a student class, right? Like this is a sample program. In our next lecture we will go through this. Okay, we'll go through this review. And what I was doing, so if you go to my account, Replit account, you see that one is reference parameter. These are the questions. These are the questions. These are the questions. Our test in your test. Okay, so these are the test question. Okay, so you will see output. So while you see your grade, you will see the link of this program. Okay, in grading rubric, so you can go there and practice. But in our next lecture, if needed, I will go through this. Okay. How many of are you there? Okay, we have maybe 10 more minutes, right? Yeah, we have 10 more minutes. Let us go quickly. So in our test, in your test, there is a question like this one, right? Okay, so you are asked to write program code for a student class, right? So a student class contains attributes like name and number of credit hours, and these are public, and is in state, this is private, and that has a default constructor and as another overloaded constructor. Okay, so that overloaded constructor is used to instantiate student object. Okay, and we ask to use appropriate arguments. That means arguments will be this type, whatever type these are, you need to similar type arguments. Okay, and include getter and setter methods for only the private attributes. Private attributes here is in state, so we need getter and setter for the in state, and then we need to ask to override the toString method. Okay, in Java it calls it toString, and in C# we call toString. Okay, then we asked you to write a method is graduating that always return false. Okay, and the next in the main method I asked you to create two distinct student object. Okay, and to display the value of the corresponding student object without explicitly calling the toString method. Okay, that means we know that toString method is not needed to call. It is called implicitly. Okay, that means, okay, I specified that you do not need to call toString method, but still some student call toString method. So let us go to this program.
Hey,
Okay?
Professor, I have a question real quick.
Yes.
While we're going over test questions, could we go over the question with the reference keyword and the pre and post increments, please?
Yeah, because we need help with that one instead.
Yeah.
Yeah.
Considering the fact that like
Yeah,
80%
I
of
will
class got it wrong.
Yeah. Yeah, so with that may need more time. So we have 10 more minutes, 6-7 more minutes. So let me do this quickly. So in next class, I am telling that whenever you grade tomorrow, you will see this my program
Yep,
link.
sure. Cool. All right. See about
You
that.
will see. You will see this. Okay. You will see this. So let us do quickly. So my program is already here. So what is this? So my student class, right? Student class has a name. We know the string type, and credit hours is integer type, and is state is in state, that is a Boolean type, right? And it has asked you to create an overloaded a default constructor. Default constructor, it can be empty, or you can put default value for name and these attributes. Okay, so for simplicity you can make it empty, and this is the overloaded constructor. Okay, overloaded constructor just will this is the argument. Each of these argument are used to connect with this type. Okay, and this is the is in state. This is the in state, this method that would always return. So what is that one? It says is in state. Okay. Oh, so is in state. Okay, so you're asking to getter and setter method to write the getter and setter method for is in state. So this is the getter method for is in state, and this is the setter method for is in state. Okay, and we said that there will be another method is graduating that always return false. So this is the is graduating method that always return false. Okay, and we are asked to override the toString method. So this is the overriding format of the toString method. Okay, so up to this it is gone. Now number 6, it has asked to write the main method. So this is my main method, and it has asked to different object, student object. Okay, I can say T1 or T2 or anything is fine, or S1 and S2 is fine. Okay, you can say S1 and S2, or T1 or T2, you can say anything, no problem. S1 and S2. Okay, These are the things. So you do not need to explicitly call toString method. It will come automatically, right? Okay, so if you run this program, then it will give you result. Okay, so this is the program written in Java. Okay, so if we want to convert it in C#, let's just 2 minutes matter. Okay, so if I go to replete account, .it C#, name, I usually give same name, C#. Okay, I want to copy.
Hey, Professor Mokhtar, if we named the
Yes.
students Terry and Jerry, could we have gotten extra credit for that?
What is that on?
If
Okay,
we named the students Terry and or Jerry, could we have gotten extra credit for that? Just a question.
No, I don't have any extra credit option for this program. Okay,
Yes.
so I want to quickly convert this Java program into C#. Okay, let me quit the class. I want to discuss, maybe if needed, we will discuss in next lecture. Okay, so one thing that this class must be outside of another class. Okay, so some people, a few of them put a class into another class. Okay, so this class can be up of main class or bottom of main class, no matter, it will work. Okay, either you put up or main down, but it must be outside and it will work. And then we need this program, this in the main method. Okay, so let me copy. I copied and paste this. So I copied and paste this actual code from completely just Java to C#. Okay, now please help me. What changes I need to do? Okay, let me do from the main method. In the main method, I need to change system.out.println by console.writeLine, right? Do you understand this? So main method is change is very simple. Okay, so then what changes we need to in class decoration in C#? You wanna help me?
Using system.
Okay, so we need to make string is all string should be going to lowercase, right? It's okay, you can put uppercase, but all string should go in lowercase, right? Wherever you see string, all should go in lowercase. Okay, that is done.
The toString, you put override into the to the header.
Yes. Yes. So here, instead of override annotation, we say public. We say override here. Override string, and toString 2 is in uppercase in C#, right?
Yes.
Okay, and then what changes we need to do? And this is done. And another thing is that we know that Boolean C# does not have Boolean, it has bool, right?
Right.
So I need to get rid of the EAN. So now it is Boolean, bool. So from here and here, oh, I'm sorry. Okay, it is bool. And here I need to get rid of Boolean. Okay, and here I also get rid of Boolean. Okay, here, right? Okay, what other changes I need to do? Is there anything else? So I change string, I change bool, then I changed overriding. Anything else you see? It should work. Let us see if there is anything. Okay, that's all. Now it is working. Okay, this program was this is the problem that you are asking in your test. Okay, in our next lecture, so by tomorrow or by this weekend, you will see your test grade.
But wait, sir.
Okay.
Sir.
Yes.
We need
Yes.
help with that one question. The ref.
Yeah, reference keyword we will discuss. We are out of time.
But
Okay,
you
we will
said-
discuss in next.
Well, on Tuesday, you said
Professor,
you
with
were
all
gonna
due
do it
respect,
today.
I will literally ask you this question at the beginning of next class, and please, I am begging you to answer it.
So the reference parameter.
Yes, the reference question. Like you said, we can do it next class, but please, I will ask you it next class, and please answer it.
No, because I don't have time. Oh, okay, one thing that. So whenever you see your test grade, you will see that in the what is that called, in the grading rubric. I have added this specifically this URL. I told you that. See the example code over here. So then if you come here, this code, when you see grading rubric, then you should hopefully you should be able to come to this program and you should be able to run this program. But if you cannot, okay, or if you do not do that, then what will happen? I need about 20 minutes. What I want to do, I want to go thoroughly from the beginning. A lot of students, they mistake reference parameter. So I want to spend at least 20 minutes to discuss reference parameter from the beginning. So then you need a fresh mind and brain so that you give attention at least 20 minutes. Okay. And then if you remember, if you go to this lecture, I think if you go to this lecture, we discuss reference parameter, this question, right? This lecture. So actually, if you go to this lecture, right? Then maybe upstairs class X, but reference
Like, comment,
parameter. Why
and
did
subscribe.
this is reference parameter at the beginning? In this lecture, we discuss reference parameter. Okay, here. Maybe it has 20 or 30 minutes lecture. So if you review this lecture, then it will be fine. Otherwise, I want to spend completely or revisit this, but it will take 20 minutes at least, or maybe 30 minutes should be better. That I can do in a fresh lecture, okay? But whenever you see your grade, you will see that I compiled that program, and you will be able to see this program. And you can run this program, and if you run this program, you should be able to see output, and you can recall what happens. Okay, except this reference parameter, is there any question about object-oriented programming principles?
No.
Okay, that's good. If you understand object-oriented programming principles, yes. Yeah, I promise I will discuss reference parameter again, okay? No problem. But so we have now finished object-oriented programming principle, okay? And these are what we discussed so far. It's called object-oriented programming foundation. So if you understand these, then your higher level programming will be easier. And all you will implement all of this concept in your advanced programming. Okay, so in our next lecture, we are not going back, we are not discussing any more object-oriented programming principles, okay? But only thing I will go with the reference parameter. Okay, good luck. Anyone has any question? Okay, if you don't have any question, then I can wrap up today. And thank you so much, and you have a good night.
Nani?
You have a wonderful night, Professor.
Thank you.
Good night, Professor. Thank you.
Goodbye.